Day 31 notes, pre-calculus. In a continuation of our discussion of circles and equations that represent circles, I'd like to start with problem number 55 from section 2.2. I'd like to find the equation of the circle whose center is at 2, -1, and has a radius of 3. Only differently this time, I'd like to record our answer in what's known as expanded form. So let's start off by representing this equation in a simple form. So here we know the center is at 2, so I'm going to write x minus 2 squared plus y plus 1 squared. Since our center is at positive 2, -1, we use the opposite of each number in the equation. And the radius is 3, so I'm going to say that that equation is equal to 9. So this equation does represent the points that lie on the circle. However, I would call this a simple form. Sometimes we're presented with an equation of a circle in what's known as expanded form. So let's show what that would look like. Basically, all we have to do is calculate the results here and expand the binomials x minus 2 and y plus 1. So x minus 2 squared is the binomial x minus 2 times x minus 2, and for the binomial y plus 1, that's y plus 1 times y plus 1. And all of that is equal to 9 currently. When multiplied here, we get x squared minus 4x plus 4 plus y squared plus 2y plus 1 equals 9. And lastly, we'll reorganize this in standard form. That's where our largest exponents are listed first. And we do go in alphabetical order there. So x squared plus y squared, then minus 4x plus 2y, plus 4 and plus 1 can combine, since they're like terms, to make plus 5. And all of that is equal to 9. The last step in creating an expanded form equation is to set it equal to 0. So this would be x squared plus y squared minus 4x plus 2y minus 4 equals 0, because I subtracted 9 from both sides of the equation. And this equation here also represents the circle with a center of 2, -1, and a radius of 3. However, this is the equation represented in expanded form. Let's think of another one. Here the center of the circle is at the origin and it passes through the point 4, 7. Sometimes we have to get a little bit creative when we find our equations because our values aren't quite as obvious to us. We know that the center is at the origin, so we know the first half of our equation is going to look like x squared plus y squared, but we don't exactly know what the radius is. All that we know is that the circle goes through the point 4, 7. Now, if I had a sketch of what that might look like, here's an x and y coordinate grid with the center here, and then we have the point 4, 7. So 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7. We're somewhere up here, and that circle has to go through those 2 points. Now that circle, okay, so it's centered here. It's going to come around that origin here. Our job is to find the radius next, because if we had the radius of this circle, that would help us identify the equation of the circle. So the radius would be the distance from the center to the edge of that circle, and we can find that distance using the 2 points, 0, 0 and 4, 7. So as a side note, let's go ahead and calculate that. The distance between A and B, we'll call them, is equal to the square root of 4 minus 0 squared plus 7 minus 0 squared which is equal to the square root of 16 plus 49, which is equal to the square root of 65. Now I'm going to leave that as it is. Okay, I'm okay with that distance being a square root here. Don't necessarily want the decimal. And the reason for that is because our equation should be x squared plus y squared equals the radius squared. Well, if the radius was the square root of 65, we turn around and square that, what would the equation then look like? Well, here you should recognize that the square root and the square, or this power of 2, essentially cancel each other out. And what we're left with is the equation x squared plus y squared equals 65. Now, if I wanted to record this in expanded form, there's not a whole lot of expansion that I have to do on the left side, but I do want to set this equation equal to 0. So we'll call this x squared plus y squared minus 65 equals 0, and that would be a nice solution. This is the equation of the circle in expanded form. Let's look at one more example. I believe this is number 63 in our text. Number 63 presents us with an image here, and we have to determine the equation that represents this circle. Let's go ahead and identify the parts if we can. Its center is at -2, +2. So we have a center here at -2, +2. And the radius then, if this is the center of the circle and the distance to the edge, well, that's another 2 units. So we have the center at -2, +2, and the radius is equal to 2. What that then implies is that the equation could be represented with x plus 2 squared plus y minus 2 squared, and that result is equal to the radius squared, or 4 in this case. 2 squared is 4. Written in expanded form, we'll have x squared plus 4x plus 4 plus y squared minus 4y plus 4 equals 4. Rearranged in standard form, x squared plus y squared plus 4x minus 4y. 4 plus 4 makes 8, but then we're going to subtract 4 from the right-hand side, and that leaves us with another plus 4, and that equation is equal to 0. So I simplified that, a lot of it in one step there. Replay the video if you didn't follow along with that, or write out all of your work and show your steps, and you should see a solution that simplifies to the same result as well. This would represent the equation of the circle written in expanded form. For our assignment tomorrow in class, we're going to complete problems 53, 54, 56, 58, 59, and 61. They all have to do with writing equations of circles.